Hello everyone, I'm Dr. Mehraei and we are continuing with second question of tutorial number 7. So suppose that we have two populations which are normal distributed with equal value of variances. We take a sample with size 9 from the first population and find out that the mean and variance of the sample are 47 and 3 respectively. In addition, we take a sample with size 53 from the second population and find out that mean and variance of the sample are 45 and 10 respectively. Construct a confidence interval with confidence level of 95% to estimate the difference between population means. So whenever we ask you about confidence intervals regarding two populations, we are dealing now with difference between population means. So when I want to construct the confidence interval, I'm talking about difference between means of population. And when I want to estimate it, this is x bar 1 or x bar x minus x bar 2 or x bar y instead of mu1 minus mu2, because those are the parameters, the difference between population means. That's the one we are predicting. We could say mu1 hat minus mu1 2. That's the one we are trying to find the confidence interval for. For the point estimator, okay, this is x bar x minus x bar y. Okay, first thing first, we can find our alpha, our error, which is 1 minus our confidence level, which is 95% in this case. So 5% is our alpha. Now I should know which case I should apply for my confidence interval. I have already mentioned about all of the cases in lecture 7. That's why please go through them very carefully. And let's also check for this question as an example together. Okay, so we have two populations, both of them are normal distributed. Okay, this is good news, at least they are normal distributed. But this is not good enough for us to make sure that I should use Z in my reliability factor. We should check other conditions. Their variances are equal. I don't have any information about the value of variances, but I know they are equal. This is a good thing. Otherwise, I should have used the approximation of t-distribution, which is out of the scope of this course. So we take a sample with size 9 from the first population. The sample size is not big enough for the first one. But when you take a look at the second sample size, this is 53. This is big enough. But you know, whenever we talk about two populations, we are comparing them. So it's very important that both of them should be big enough. Even if one of them is not big enough, so we cannot use central limit theorem in that case. So this is not the case for this time. So now let's take a look at our conditions again. My sample sizes are not big enough, but my populations are normal distributed with the same value for their variances. So in this case, I can use t-distribution. And for that, I should calculate pooled variance, S power 2 for P. So SP power 2. And this is the formula which I also provided for you in the lecture. And instead of df, I inserted m plus m minus 2. Here, since I've calculated it, so you could use it inside your formula anyway. So please make sure, whenever we are talking about degree of freedom for t-distribution, whenever it's about one population, this is n minus 1. When we talk about two populations, this is n plus m minus 2. Or n1, our sample size 1, plus n2, sample size 2, minus 2. Okay, so for the rest, I just assign the values to it. I have the information about the variances of my samples, not population, so I use S2. And that's how all the time we calculate the pool variance. And this is the value for that, and we should be careful in the formula I used for confidence interval. I use the standard deviation here. In some books, you can see they use the pool variance inside the square root. It's based on your taste. It depends on your taste. You can use this value to divide by n once and then divide by m, or use this formula, which is easier for calculations after that. So here I should see how can I come up with my reliability factor. So we decided this is t-score that we should use instead of z-score because I couldn't use central limit theorem and I didn't have information about my parameters. So here alpha was 5% when you divide by 2. This is 25 over 1000. Degree of freedom is 60 as we calculated. Now let's take a look at the table to see how we can read the t-score. And by the way, I provided you another t-distribution table because this one, the other one in the lecture was a little confusing for students. It had one-sided and two-sided terms inside it, which is very useful for hypothesis testing. You can find the answers very fast. But I prefer that you guys learn this one because as soon as we learn about the logic and I show everything for you in hypothesis testing about the pictures for the normal distribution, that how can we find out about p-value and also alpha at the same time, then you won't even need that one-sided and two-sided thing. Okay, so here, by the way, alpha that appears here is not the one that you calculate from the beginning of the example. Alpha here is the probability, which is inside the argument of your reliability factor. So this is actually this one. 5% divided by 2, which is 25 over 1000, this one. And please distinguish between t-distribution with standard normal distribution. For normal and standard distribution, we have probabilities inside the table. But for t-distribution, we have it above that. You see, the probabilities are here. Here we have degree of freedom. And inside it, we have t-score. This is different from a standard normal distribution, as we know. Okay, so the probability is 25 over 1000. Degree of freedom, we calculated to be 60, so the intersection is 2. That's why inside the formula I used number 2. Where is it? Yeah, here we assign the numbers here, so we find out that this is 2. Okay, then we should calculate this one, and the rest is just calculations. And as you can see, we find out that this is the confidence interval. So what does it mean? It means that the difference between two means, I mean the difference between means of two different populations, we estimate that 95% confidence falls inside this interval. And you know, whenever one of them is negative, the other one is positive, it shows that 0 is inside this interval, which has a meaning. In hypothesis testing, I will talk about it in details, because when we have mu1 minus mu2 equal to 0, it means that it implies that mu1 is equal to mu2. It means that we are predicting that means of two different populations are the same. So this is a test that we will do, we will apply later. We will test it that whether the population means are equal in two different populations or not. That's what we will talk about later. That's why it's interesting to know whether 0 falls inside our confidence interval or not. And as you can see, this is the beauty of confidence interval, that we can give confidence level to it, and it's much better than just calculating 47 minus 45 and say this is just 2. You see, this is now totally different, the answer that we found here. Okay guys, I hope it was useful for you, and in the next lecture we will talk about hypothesis testing in details. See you guys.